Welcome, folks. I see folks coming in from the waiting room. We're just going to give it just a few more seconds to let the waiting room clear out, and then we will get started. So, thank you for your patience. All right, I think the waiting room is about clear, so we will go ahead and kick off. Thank you all for joining us for this LF Energy webinar on EVerest for production. We are privileged to have with us today two experts on the EVerest project from Pionics, Pete Gomful and Kai-Uwe Hermann. Thank you both for joining us. For everyone who's listening in, if you have questions at any point during the webinar, you will find a Q&A button in the Zoom interface. Please feel free to click that button and submit your question. When we get to the end of the webinar, we have reserved time for Q&A, and we will go through as many of those questions as we possibly can in the allotted time. And I will type a reminder about that in the chat as well. So with that, thank you again for joining, and I will turn it over to Pete to kick us off.
Yes, hello everyone. Also from my side, excited to present the EVerest project and respective updates to you today. This is the agenda and the topics we prepared for today. There will be a short recap of what EVerest is for the ones who are not that familiar with the project yet. And then we will talk about the migration of EVerest from a multi-repository approach to a mono-repository structure and how it looks like. There have been major feature additions and contributions in the second half of 2025. We will also present those and go into detail. We have introduced a plan for stable releases and the corresponding infrastructure, and we will present how that looks like. And we have a brand new documentation for the EVerest project with lots of additional resources and a little bit of a different look and feel. We will also look into that before we finish off with updates on certifications and the roadmap ahead. And I would head over to Kai for this.
Well, also a warm welcome from myself. I'm just going to give you a quick recap, basically what EVerest is in a couple of short words. So it's an open source software stack for EV chargers that is developed under the Linux Foundation Energy. It is released under the Apache 2.0 license, which is a very industry-friendly license. Targets embedded Linux as its platform to run on, and has the aim of supporting as many different hardware platforms as possible, and is designed with the idea in mind to hopefully standardize and accelerate the development of EV charging infrastructure with a common software offering. So next slide, please. Couple of the main features of EVerest. It's built on top of a very modular and extensible architecture. There is support for AC and DC charging and all of the relevant EV charging related protocols. So on the backend communication side, we cover OCPP 1.6, 2.0.1, and 2.1. On the car communication side, we cover everything from the ISO 15118-2 and -20 up until back to the DIN spec 71-1. There is energy management implemented, as well as an API or multiple APIs actually to talk to this energy management. You can make use of a over-the-air update module within EVerest using Rauk, but there's also an API to implement basically your own update service. We're trying to follow best practices in security. We have a vulnerability management team, and try to fix security bugs as fast as we hear about them. There's a lot of hardware drivers in the project already for a lot of, let's say, very common hardware out there. So drivers for different charge controllers, for different power meters, isolation monitors, power supplies, RFID and NFC readers, payment terminals. For building embedded Linux images, there's support in the form of a layer for Yocto. And another thing on the security side, there's also TPM support for private key storage, which is also relevant for some of the features like plug and charge, etc. If you want to know more about basically what Everest is all about, how it is structured and everything, I can recommend our last webinar from the summer of 2025, where we go into a lot more detail here. Then, as Pete already mentioned earlier, we have decided to switch from a multi-repository to a mono-repository approach in the last couple of months, which basically means a lot of the functionality that was spread out over multiple repositories in the past, like libraries like libocpp and libISO 15.11.8, are now developed inside Everest core/lib. And on the right side, you can basically see a extract basically of this new structure. We have an applications folder where some support and usage applications are implemented. This library folder with a couple of very important libraries, foundational libraries, and also basically the idea of having functionality available for all of the other parts of the system as well. And in roughly the same period, we also restructured the directory structure of the module subdirectory. So they are now grouped by the area of concern. So you can see we have an API directory which bundles a lot of the API modules. For hardware drivers, we even have a different subdirectory structure underneath it that basically splits all of the available hardware drivers in their respective area of concern. Things like isolation monitors and power meters now in their own subdirectories. Next slide. So now basically what's new in Everest since our last update. We have added in a big code donation from Bionics in September a stable versioned MQTT based API mechanism with the idea of offering an API that basically anybody can program against with some guarantees regarding backwards compatibility. This API is built on top of Async API 3.0, which means there's an API specification, but the actual implementation can be done by anyone who wants to use it in the language of their choice, as long as it can serialize and deserialize JSON and speak MQTT. These APIs also offer some form of bidirectional health monitoring, so the user of the API and the Everest system know if both of the module parts or both of the parts that talk to each other are still available. And the APIs are themselves, they are implemented as Everest modules. So they make use of the same like flexible configuration mechanism that we already have within Everest. You can go to the next slide, please. So this is a simplified diagram of how this basically looks like. In the bottom, you have the so-called Everest environment. This is basically where the Everest manager and all of the typical EVerest modules for, let's say, running the charging logic and some hardware drivers live. And on top of that, you can add all kinds of different functionality. For example, if you want to implement a custom power supply that isn't upstream in EVerest and you don't plan on upstreaming this, for example, you could take the power supply DC API and basically program a driver against this async API description and run it. And yeah, next slide, I think, is back to you, Pete.
Yes. Together with the APIs, we also contributed BringUp modules that are development helpers for isolated hard and software development that allow you to bring up your hard and software components in isolation. These BringUp modules, and we will look how this looks like in a minute, are implemented as EVerest modules, so you can load them in your EVerest configuration. And they come with an interactive UI that allow you to communicate to and from EVerest. So you can basically mirror what EVerest would be communicating and would be receiving from your implementation or to your implementation from within these BringUp modules. So what they do is they basically make it very easy for you to integrate EVerest, because you can basically test your integration in parts. Start with an integration of a power meter or a power supply or whatever component you want to integrate, and bring up EVerest step by step and independently from a full charger development. So you can really break it down into individual parts. That also allows you to do easier qualification of potential hardware components and not to miss any problems in an early stage, but test it individually in the beginning. These are some examples of many BringUp modules that are provided. So there is basically a BringUp module for every hardware component that you can integrate. These are just 4 examples. On the top left side, you see a BringUp module for an isolation monitor and a DC power supply. Then for a power meter component, for the Slack integration if you want to do that externally. And on the next slide, I prepared a short video that explains a little bit how you can work with these BringUp modules. And I will pause the video a little bit right in the beginning. So what we have here is the MQTT Explorer, so an easy UI tool to visualize the MQTT communication. And it also allows you to publish on certain MQTT topics. So we run this on the left side, and on the right side, what we first do is to look inside the EVerest config that we plan to use. So if you are familiar with EVerest configs, you can see this, that this is a very minimal config with only 2 modules that we load. One is the EVSE board support API. So that's one of those APIs that Kai explained previously that allow you to integrate, for example, your low-level microcontroller implementation that handles the PWM and safety, and integrate this with EVerest. And the second module is the BU EVSE board support, so for BringUp EVSE board support. And that is the graphical user interface that allow you to interact with your implementation. What we do here is we start up the manager process, basically the API module, and then the second tab, we start the BringUp module to have this on the full terminal right here. And on all the gray areas, you can see information that can be sent from your implementation, or in that case, from the MQTT Explorer to EVerest. So if we share any information here, and we will do that in a second, then we are able to see this here, and that means EVerest registered the data that has been published and can basically work with it. So you can see like CP states like ABCD that you can share here, the state of the relay, of the proximity pilot, hardware capabilities, and other information. And basically everything that's colored right here are commands that you can send from EVerest to your implementation. In that case, just a command via MQTT that we will see visualized here in this MQTT Explorer. So this is the topic. You can see that there's heartbeat communication going on. And if we publish an event in the MQTT Explorer or potentially your implementation, you can see that EVerest is registering this and displaying it. And at the same time, we can also send events from EVerest to the application or your integration, and you can see this command coming up right here on the left side. So that makes it very easy for you to integrate your components in isolation. As we mentioned, there is and quite extensive support for existing hardware that is related to a charging station. You can see a list of supported devices right here. I won't read out all of them, but the ones that are highlighted are the ones that have been added in the second half of 2025. So 2 power meters have been added, one from AST, the DC650, and from DZG, the GSH01. 2 power supply units from Huawei have been added, as well as components from InfiPower, UU Green, and Winline driver. For the board support packages, there was a contribution for Texas Instruments EVSE controller that is integrated in EVerest. We have a new RFID reader module and have integrated the isolation monitor from Bender. And I will head over again to Kai, who will present the release process.
Yes. Basically, for the last, I think, 2 years, we've been in a relatively regular cadence of monthly snapshot releases, and every roughly 3 months, we have released a so-called like consolidated or stable in air quotes release that had a bit more testing going on, but not a lot of backports or things like that were happening to these branches in the past. However, we have now decided that we want to switch up this model a little bit. So basically, we want to introduce a new stable release cadence of roughly every 6 months that corresponds with the introduction of some stable release branches where these stable releases can live on. There'll be coordinated testing period before each of these stable releases with the community and select partners for making sure that the stable release is as stable as possible. And we also will do some more continuous testing as well, which we call this new stabilized main approach, which basically will help to make the whole project, I think, run a lot smoother than it already is in the future. As I already mentioned before, there is what makes this stable release cadence, I guess, interesting is that we now have a public API definition to program against EVerest, where we can also give some guarantees. And as I already mentioned in the beginning, there is now basically a policy of some form of community maintenance for the latest stable release. So obviously, we won't be backporting every new feature to a stable release branch. This will still development will still happen in main, but select features might get backported to stable releases, as well as certain bug fixes and security fixes as well. However, we will discontinue the habit of monthly snapshots because, as I already mentioned, this kind of gets replaced with this stabilized main approach, basically. So if you want the latest and greatest, you should be able to run against main or within a couple of commits when some heavy development happens. And if you want to have something with more stable, then pick the stable release branch. I think now you can switch to the next slide, please. All right. So what does this public API actually integrate or include, basically? It includes the async API definitions I mentioned earlier, as well as the upcoming energy management JSON RPC API that ChargeByte has been working on. It includes the EVerest module configuration. So basically, adding new configuration keys into your config that would break the configs that are required wouldn't be allowed in a stable branch, for example, if you backport something. However, things that are optional, for example, could be added. This also means the OCPP configuration is part of this public EVerest API. So there also changes will be relatively conservative, as well as the internal module sources. So if a module writes to its own database, for example, this stable branch would guarantee that within this stable version, no changes to the module would significantly change the internal module storage. Or if that happens, there would be some form of conversions happening. So what this means, we will guarantee that no breaking changes are backported to these stable branches. And additionally, we try to keep breaking changes as minimal as possible across major releases, so across different stable releases. However, another note in the bottom here says the internal API between EVerest modules, so everything that is not part of this public API that was specified above, but the actual super internal communication between the modules is intentionally not part of this definition. We will try to keep this as stable as possible, or as non-breaking if any changes happen there, but it is not guaranteed. So if you rely on some internal functionality, it is definitely worth paying close attention to the release notes still. So next slide, please. And probably the most exciting part of this new release process, the way we're gonna version things. Not much will change from the outside, I would say. We will keep this calendar-based versioning that we have already ongoing. So year, month, and patch release number. The actual APIs themselves are versioned separately. So the external async API right now is in version 1.0. The upcoming energy management JSON RPC API will also be versioned separately, and maybe the EVerest and OCPP configuration might also be separately versioned in the future, but it isn't really much decided. And for the branches, we'll basically have a main branch with all the active development going on, and various stable branches that just get the prefix stable and the year and month date, and yeah, they contain all of the mentioned stabilized parts of EVerest. Yeah, and I think that's it from my side.
Okay. And I will introduce the new EVerest documentation that applies the diataxis format, which means that every part of the documentation of EVerest can be sorted into one of these 4 categories: tutorials for learning-oriented content, how-to guides for goal-oriented content, explanation for understanding-oriented content, and reference for information-oriented technical resources. So a little bit of a restructuring. All of the resources that have been available in the old documentation have been ported over, potentially updated, and there are quite some new resources available. Actually, we plan to have that migrated until today, but there's still the preview available on that link that I would also like to present to you. So I will switch over to it. This is how it looks like, a little bit of a new look and feel. We are looking at the documentation entry point, and you can see a quick access to a high-level overview, to the quick start guides that we have available, the GitHub source, and the discuss and collaborate section. And then you will find the different sections of tutorials, how-to guides, explanation, references, and a separate section for Q&A here. You can break it down, look into the how-to guides, and get insights on plug and charge, on ISO 15118, and lots of additional resources. What is probably familiar for most of you who worked with the documentation before, we still have the reference section for our EVerest modules. They are now sorted into their respective directories. So you can find the documentation also on the left side here, and see the reference documentation for the EVSE manager. What also has changed is that we included the handwritten manual documentation in one page, and the auto-generated reference is down here, so you can find all the module configuration and what interfaces the module provides and requires down here. And you have that for all the modules. You have that for all the EVerest interfaces, the internal ones though, and the types. And what is new is this API specification. The new feature we talked about, the new integration APIs based on async API. And you can find all the references here as well. So you can, for example, look at the power supply DC API. What you find here is the async API specification. And maybe this path looks familiar to you because we used it, or a similar one also in the short demo about the BringUp modules. So this is, I think, some nice documentation and nice resources to work with. And you can also see that the async API approach that we took is also very modular. So you don't need to integrate all of these APIs, of course, just the ones that you require when you use or plan to integrate EVerest. And there's also quite an extensive documentation of how to get started with it and how these APIs work in a separate section down here, for example, that explains it quite well. So feel free to have a look at it. And of course, we're also always happy about any kind of feedback for this. Right, so we're moving towards the end of the presentation. There are a few updates to share about certifications. So some of you know that the EVerest project or EVerest-based chargers are already certified from multiple vendors and in different products for OSPP 2.0.1 for the core and advanced security profile, and I think also smart charging was certified recently. Basecamp received the OSPP 1.6 stack certification. So what was Basecamp was a product of Bionics that has now been fully open source. So the EVerest stack was part of that. We cannot call it the EVerest stack certification, but technically, if you use EVerest, you can be really sure to use an OSPP 1.6 compliant stack for all feature profiles that are available in OSPP, so including security white paper and smart charging and additional blocks. The EVerest stack has been plug and charge certified, so that's really the EVerest stack by Hubject by passing the EVSE check. So we did the certification for all profiles, you could say, so for AC plug and charge and DC plug and charge, as well as for OSPP 1.6 plug and charge and OSPP 2.0.1 plug and charge. So all of that is certified within the EVerest software stack. And what else is great news is that EVerest has been selected as a golden system under test by the OCA, which means that EVerest will be continuously tested by the team that is developing the testing tool for OSPP, which is called OCTT. And this continuous testing definitely helps the project, of course, because it also ensures future OCPP compliance in a way. Okay, we also want to have a quick look at the roadmap ahead with you. This is still a little bit of a preliminary roadmap, so it's of course also it also depends on feedback from you as the community and the respective priorities. For OSPP, what we have today is full implementation of 1.6 to 0.1 and also 2.1 core. And the plan for the first half of 2026 is to unify the storage of the different OSPP versions. So that is currently that's something that is separated between the protocol versions. We want to combine it. And that will also allow easier switching between the different OSPP versions, also at runtime. And then we'll, of course, focus on the implementation of OSPP 2.1 of the new additional functional blocks like BPT support, frequency control, EMS support, and also ISO 15118 smart charging. And in the second half of 2026, we will continue with the remaining functional blocks of the specification. For ISO 15118, we already have support for -2 and -20 AC and DC state machines, and also support for megawatt charging on the high-level communication layer. In the first half, we plan to continue to implement -20 with focus on the AC V2X amendment and the V2X DC frequency control, as well as MCS low-level communication. There's a group working on the integration of GBT, and there are 2 small parts left in the -2 that hasn't been implemented by many EVs, which is why we didn't put a high priority on this, which is the certificate update feature and the smart charging functionality of the -2. And we plan to implement this as well. And in the second half, we plan to look into the remaining features of -20, like plug and charge and DER support. There is also a group of people that is currently working on the integration of the -2 and basically an additional library in libISO 15.11.8. So we have a working -2 implementation, but in order to make this more flexible or potentially also use this on the EV side, there's a group of people working on it to basically re-implement or add an additional implementation for it. And we will also look into extending the EV simulator, which is based on this libISO 15.11.8. Or energy management roadmap, of course. But today we have basic load balancing functionality in EVerest already. A very flexible and expandable energy tree architecture that allows you to define any kind of composition for your installation, and also a quite easy integration into energy management systems that want to control EVerest and the power of EVSEs. And in the first half of 2026, we also need to make some adjustments to the energy management modules and potentially respective interfaces to comply with 2.1 and -20. So this all goes hand in hand. There has been work done on the EEBus integration, which is currently ongoing, and we plan to continue. Kai already mentioned that there will be a new JSON RPC API that's dedicated to the energy management integration of EVerest, providing some more information and control. Sunspec is going to be implemented in the first half of 2026, potentially as a separate EVerest module. And we plan to extend the load balancing functionality to be more dynamic in the future. Before we look into different interesting protocols in the second half of 2026, like Matter and OpenADR, and also potentially further extend the energy management capabilities for like solar integration and dynamic pricing in the future. This is our last slide with some references to the code, Zulip chat, where you can reach out to us, ask questions, or add comments. You can find the current documentation here, and the EVerest meeting calendar, where you can join any of our working groups. We have the mailing list, and there's the link to the YouTube channel where you can watch the Technical Steering Committee recordings. Thank you.
Amazing. Thank you both for such a great presentation. I just want to remind everyone, if you have questions, we are happy to take them now. Just click that Q&A button in your webinar interface and you can submit those. We do have a couple questions, so we can jump into those. The first one is, in the old documentation, there were a few pages with a TBD annotation on them. Is the documentation now complete, or is it still a work in progress?
Well, I guess with a project that adds new features, it's always work in progress, of course, because we always also extend the documentation. I'm not sure which parts were referenced with the TBD, but of course we worked through the complete documentation again in this new part. So I would assume that many of these things have been sorted out. What was basically happening in parallel was the whole migration to the mono repository. So we are aware that a couple of documentation still needs updating, targeting this new mono repository approach, because there were some chapters where we were like referencing different libraries, or also the whole getting started section with setting up an EVerest workspace is not really required anymore with everything inside the mono repo. I think that became a lot easier. And those are some things that we are aware of and will also target in the future.
Wonderful. Next question. Does Everest already support secure TLS SSL connection to the MQTT broker?
I can take that. Not at the moment, but if there's interest for it, please don't hesitate to like open an issue so we know this is something that people want. Since typically the broker that Everest runs on is a local broker, and you can restrict basically access to it in other ways. We haven't really done that, but for certain use cases, I see that this can certainly be useful. So might be coming in the future.
Next, due to rising RAM prices, is there any effort going on to optimize that aspect of the framework?
I can take a guy, I don't know.
Sure. Yeah.
There have been ongoing optimizations in the EVerest framework quite recently, where we were able to heavily reduce the number of threads that have been used by EVerest. And added optimizations for quite a low level of the MQTT communication and framework, and we see that some positive results for this when it comes to running on lower edge hardware. Although it for the chips and CPUs that we worked with, we haven't really identified issues with 1, 2, or 3 EVSEs that run Everest. The issue can pop up, or like a performance issue can pop up if you want to run Everest in an architecture where you have a lower edge system and you really want to run like 20, 30 EVSEs at the same time, all on the same hardware. We actually haven't verified the optimizations that we've done in such a setup, but there have been quite some improvements also on that level. I'm not sure if you want to add to it.
No, I think you've said everything there is to say at the moment.
Okay, great. Next, I've seen that you have archived the dev environment after the last merge. Is there a plan to integrate it in the main repo?
I think I can take this. Depends on the definition of integrate, I guess. It is already integrated in the main repository in a sense that the application is in there, and I think I would have to look this up actually if it's already used directly. So the parts of the dev environment that are basically just the application, the dependency manager. If I'm not mistaken, this actually gets automatically installed into a Python virtual environment during the build at the moment. But there have still been some discussions ongoing if we want to drop this part of the dependency manager maybe altogether, since now most of the stuff is already in Everest core. So well, we'll see where this is heading, but most things that still need doing in this case, I think, are still part of the documentation that will be published soon. Yeah.
Perfect.
Hope that answers the question.
Next, the platform is built from a very large number of different subsystems, frameworks, and language runtime dependencies. Is there any roadmap to rationalize this by porting code bases to common baseline platforms?
I can start maybe. So a lot of the subsystems and frameworks that are potentially mentioned in this question, and also language support, is optional in EVerest. So you have the option to write modules in C++, in Rust, in Python, and I think still in JavaScript, although we decided to remove at least all the JavaScript modules. I think the framework still supports it. But for production environments and production builds, you can break it down to really only what you need. So a lot of these framework support and language support you can disable. I think by default, for example, Python is enabled to, because we have a lot of software in the loop modules that use Python. We have, that's for like demo and getting started purposes, of course, quite interesting to use. In general, I think everything with like setting up your project and getting started became a little bit easier with the monorepo migration, because now we have all the dependencies in one place. There is still the EVerest dependency manager, which was maybe not that easy to understand in the first place, how like dependencies were put in. I think all of that became a little bit more clear. So I would say already today, you can break down your system and also your dependencies into quite a small set.
Great.
I hope this answers the question.
Okay, perfect. Next, there are more and more distributed charger topologies. The power modules in some central cabinet with DC cables to dispensers/front ends. Does EVerest support such setups? Or to be more precise, is it possible to run different parts of the stack on different machines?
So I'm not sure if I get like the question or the setup correctly, but what the APIs we presented, I think APIs we presented allow you to basically run like drivers for these dispensers and power supplies basically wherever you want using the APIs. In EVerest, you can just load the respective module, API module, and connect your implementation that can potentially run on a different device to it. So that shouldn't be a problem. Running an EVerest application on different hardware and like have a set of common EVerest modules that shall be used. So these kind of modules are, for example, you want to have one OSPP connection, you want to have one authorization manager, and combine that with an EVerest instance that's running on another charger is something that we discussed a lot in the past. There are ways to easily set it up, but if you think about issues that can arise on the transport level and in the network with modules being available or not, this also comes with quite some complexity. So actually in the past years there was a little bit back and forth if we want to support such architectures, and we actually have some good ideas to implement this, but so far they haven't been prioritized.
All right, thank you. Next question. The NC RFG version 2 grid code scope with AMD1 ISO 1511820 implementation will be positioned somewhere in the future near-term roadmap?
So I'm aware that a group of people is working on the Dash 20 Amendment 1. I'm not sure about the NC-RFG v2, so I would need to talk to the experts for this one. I guess Kai also doesn't know it because he's also not that much involved in the ISO development.
No, unfortunately not.
Okay.
Those are all the questions we currently have. We do still have some time, so we can give it a minute and see if anyone else would like to submit another question.
Or pick up an existing one if the response was not
Yes,
precise
follow-ups are
enough.
also allowed. Oh, here we go. We got a couple in. Would it be easy to build for build root instead of Yocto?
I think I can take that. I think I played around with it a couple years ago, and it shouldn't be too difficult. But I don't think any one of us is working on this at the moment. So if there's like some community-driven effort, sure. In the end, it's more or less just a project that C++ project that is using CMake and has a couple dependencies. It has even less dependencies now. So basically, if you look in the Meta Everest Yocto layer in the recipes there, it's not that much. And I'm pretty sure Buildroot has very similar concepts for these recipes. So I think we're not using anything too exotic, so it should be doable for someone who is prolific with Buildroot, which unfortunately I think not many of us are. And since most of our development targets platforms that run either Yocto or some other form of cross-compiled content, it's not been a big priority in the past.
Okay. And then next question, in light of all the new changes, where would be the best place for a newbie to begin?
Yeah, so with the new documentation, we have also structured our getting started section a little bit. I think there's quite some good documentation on like things like a high-level overview, how Everest is built up, and there are resources that explain it really in detail how it is built up on the inside. But if you're more interested in integrating it, you also get a good explanation of how that is done. And we have dedicated getting started guides for like getting started in software. Yeah, build Everest locally on your machine, run the software in the loop and play around with it, connect it to some OSPP server, run IS 11.8 sessions. But there's now also a new section for how to get started with hardware. If you have like hardware on the table, maybe a charge controller that you want to integrate, there's also good documentation on how to get started for this. There are people currently working on a complete new getting started guide that also handles the fact that much of the libraries have now been integrated and is now part of the mono repository. And that will probably also include a very easy getting started with Docker setup, where like you do not need to care about installing any local dependencies and you just run it and get started. So we are aware that there are like different angles from where where your interest in Everest comes from, and we try to have something for all of these different target groups, basically. And hopefully the new documentation is structured in a good way so that you also find the resources that you're looking for your certain use case.
Awesome. Well, seeing no more questions, I think that was actually probably a perfect way to end. So, well, once again, thank both of our presenters, Pete and Kai, and all of our attendees for joining and asking such great questions. This was recorded, and so we will send an email around once the recording is posted so that you know where you can find it. We will also post the slides. And the email will contain all the relevant links. So if you want to get involved, you'll be able to see how to do that very easily. So thank you again, and we hope to see you all at a future webinar.
Thank you. Bye bye.
Thank you very much. Bye bye.